Okay, here is a video to help you with your homework, the derivatives from first principles. So in class we were talking about how do we find the rate of change at any given point on a graph. So one way we can do it is we can sketch in a tangent. So it has you start at x equals 3, put the point there, and sketch in a tangent, and then try and figure out what the slope is of that tangent. That is very imprecise. I mean, it's a nice, quick, fast way of doing it, but it's very imprecise. So what we want to do is come up with an equation that we can use to find the slope anywhere along this graph without actually having to draw any additional tangent lines on it. So we're going to come up with a formula. Now, in order to come up with that formula, you need to write down the difference quotient. The difference quotient, that's that change of y over change of x. Okay, that gets us the slope. The difference quotient is the same thing as the slope formula. And we saw in class that we are going to substitute in the values. For the first point, it's going to be x and f of x. And for the second point, it's going to be x plus h and f of x plus h. Because this represents the point that we're interested in. That's x and that's y. And then the second point would be another point incredibly close to the first point so that we could then find the slope of that line. All right, so our goal is with h to become 0. We want h to approach 0. So, but first though, you're going to be writing your difference quotient. So I want to see that formula on here, the one that we can use to find slope. So I don't want to give you all the answers, so let's see what you come up with. Okay, so I want to see, it's going to be a fraction. All right, that's the hint. Okay, so get that on there. Now the next thing you're going to do is find and simplify f of x plus h. That's what we've been doing in the warm-ups. And here is your f of x. So you should know what to do now. You're just going to substitute x plus h in everywhere that you have the x and then simplify it. Then you're going to use your difference quotient. Okay, use that fraction to substitute in. You're going to substitute in this. You're going to substitute in this. You're going to substitute in this and this into that fraction, just like we did in class, and then simplify it. Okay, once you simplify that, you're then going to take the limit of that as h approaches 0, because we want the difference, the horizontal difference between the first point and the second point that we're using to get that instantaneous speed, that instantaneous rate of change. We want that horizontal distance to approach 0. So we're trying to find the limit as h approaches 0. Okay, when you do that, the answer you should get, I'm going to give you the answer so you know if you did it all successfully, you should end up with 4x minus 8. Okay, and the notation for this, we can write it two ways. Since I gave you f of x to start with, we're going to write f of x equals 4x minus 8. So this is the gradient function, or the derivative, is equal to 4x minus 8. Now this equation helps us find the slope for any point on this graph. So if we ask for f prime of 3, that means we're asking for what is the slope of the line at the point where x equals 3. So I'm finding the slope of this tangent line. Okay, so if I were to draw that in, you estimated it up here in question 1, but now you should be able to actually plug in 3 into here and find the actual slope at that point on the graph where x equals 3. Okay, I'll leave that to you to figure that out. All right, moving on to the next part. Use the derivative function to determine at what value of x the slope of the tangent line is equal to 0. Okay, so we have this formula now. 4x minus 8 gives us the slope of a line at a given point, and this x is the x-coordinate of the point. So if I want to know when is the slope going to equal 0, that means 4x minus 8 has to equal 0. And then you just have to solve for x. After you solve for x, you need to explain why does this value make sense. So when you want to explain how come it makes sense, I want you to think about the graph. Talk about the graph. Here's the big hint. When is the slope equal to 0 on the graph? Okay? So you're going to solve this equation, but then I need you to explain to me why the answer makes sense in when you're comparing it to the graph. Okay? So refer to the graph when you explain this. All right, next, use the derivative function to determine at what value of x the slope of the tangent line is equal to -4. Okay, so again, we're solving for x, find the value of x. Again, we're using the same derivative function. Okay, so very straightforward. And then, again, look at the graph. Why does that value make sense? Okay, so again, compare it to the graph. So this question, talk about the graph. This question, talk about the graph. I'm looking for sentences in English that I can read. Find the equation of the line tangent to f of x at the value of x determined in part A. Okay, so you're going to solve for x here. You're going to get that point, and then I want you to, you're going to get that point, and we know the slope. Okay, so you know the slope is 4. So we know m is equal to -4, and you're going to get an x value. So you're going to know what that x value is. And you should be able to figure out what the y value is. And then from that, you're going to write me an equation of the line, y equals mx plus b. So we're going back and using our fabulous Algebra 1 skills. If you know the slope and you know one point on the graph, you should be able to write the equation of the line that has that slope and goes through that point. So that's what I'm looking for there. All right, next, use first principles to find f prime of x for the following function. So we're going to do the same thing again. We're going to find the same derivative function, again, the same gradient function, f prime of x, but now starting with this. So you're going to do the whole process again, but it's going to be a lot simpler because the equation is a lot simpler. So you're going to be using this equation for f of x, whereas before you used this equation for f of x. So again, you're going to be running through the whole process again. So your first point is x and f of x, but now this is f of x. The other point is going to be x plus h and f of x plus h, and you're going to write the slope. You're going to write that difference quotient to find the slope through these 2 points, and then simplify it so that, and find the limit as h approaches 0. So don't forget to find the limit as h goes to 0 in order to get your f prime of x, to get your derivative function. Okay, so you're going to be doing the whole process again that you did on the front page. Okay, this whole process. You're going to do that, but starting with a much simpler equation. This one should be easier. That's why I notice I didn't break it down step by step. I didn't give you all that much room. This one should be easier because there's not nearly as much happening. The algebra is a lot simpler, but same steps as before. Okay, and then you're going to do it again. Use the first principles. Oh, sorry, did I mention this is called first principles? Derivatives from first principles. This process that we're using from here down to here, this is called first principles. Okay, sorry, I can't see what I'm doing. I don't have, zoom out. So steps 2, 3, 4, and 5 is called the first principles process. This is finding a derivative using first principles. So this is the most fundamental way of finding the gradient function, or finding the derivative function, or finding the derivative. Okay, those are all names for the same thing. So you're going to do it again. Same process again. So remember, you're going to use x and f of x for the first point, and you're going to use x plus h and f of x plus h for the second point. But now this is your f of x. Okay, same process. Do it again. All right, now given y equals this, find dy dx, and then find the points on the graph at which the gradient slope of the tangent is 0. All right, dy dx, I've written this down a couple of times today, I think. This is the same thing as f prime of x. We use dy dx when the equation given is in y equals form, And if it had said f of x, that's when we use f prime of x. So notice this equation says y equals 2x, is that cubed? I don't have my glasses on. 2x cubed minus 24x. So when we write the gradient function, we call it this. If this y had been written as f of x, then we use this. So these are the exact same thing, and again, same exact process that you did previously on problem 10, problem 9, and then problem 2 through 5. Same exact process, just like we did in class for the ball drop. Okay, in order for you to check your answers, let's give you an answer here. So let's see. When you should get the answer on number 11. You should get the answer, where is it? You should get dy dx is equal to 6x squared minus 24. Okay? So you'll know that you did it all right if you end up with 6x squared minus 24. That is the dy dx. Then you have to use this to find the points on the graph at which the slope is 0. The slope is 0. And notice it says points. There's more than one. Notice what kind of graph this is. X cubed. It's not a parabola. It's a cubic. So it's actually going to have 3 places on the graph where the slope is 0. If you put that into Desmos, it'll probably give you something like this. So it's an x cubed. How come I only have 2 places where it's 0? Oh, that's right, 2 places. Sorry, I said that. It's going to have 2 places where the slope is 0. Okay, so you can check it in Desmos as well. You can put this into Desmos or your graphing calculator, and you can see where those places are. So you are going to get 2 answers on this one. All right, good luck. See you tomorrow.